Analytical. Business experts discuss their domains in specialized jargon. Software developers talk about UI widgets, database tables, and system components. Because these two groups lack a shared vocabulary, developers are forced to act as constant translators. Every time a requirement moves across that divide, information degrades. Nuanced business rules are converted into generic technical specifications, losing their original intent along the way. This indirectness conceals deep schisms. Two team members might use the exact same term differently, and because they communicate through layers of technical abstraction, they never realize they disagree on how the business actually operates. The code written under these conditions is built on misunderstandings. The resulting software architecture is inherently brittle. When these mismatched pieces of software finally interact in production, they break. Fixing them requires destructive, costly refactoring because the core concepts were wrong from the start. A software system will inevitably shatter along the exact fault lines of a team's fractured language. Domain-driven design solves this with a specific practice called the ubiquitous language. This language rejects the impossible goal of creating a universal enterprise dictionary. It focuses instead on the precise vocabulary needed for one team to solve a specific problem. It is a rigorous, shared vocabulary actively developed by both domain experts and software engineers, applied exclusively within the isolated boundary of a specific project team. Instructive, look at this layered architecture model. A concept defined in the domain layer must retain the exact same name as it passes up through the application and user interface, and down into infrastructure. These exact terms must be spoken in meetings and drawn on whiteboards. The nouns and verbs of this shared language become the literal names of the classes and methods in the codebase. The language provides the structural backbone for the implementation. In domain-driven design, the code is the design. The ubiquitous language is the blueprint, ensuring they remain identical. This diagram establishes the baseline domain model for a cargo routing system, defining relationships between a route, leg, voyage, and port operation. In a procedural workflow, a user might state that when a customs clearance point moves, they must redo the whole routing plan. A developer might respond by saying they will update the destination field in the database and generate a new shipment table. That conversation relies entirely on generic technical actions. It ignores the actual domain rules. The software might execute the database update successfully, but it functions merely as a mechanism doing useful things without explaining its actions. It fails to capture the specific reason why the business rule exists. Perfectly functional code will still fail the business if the conversation defining it is abstracted away from domain reality. Now consider a model-driven approach, where the user and the developer restrict their conversation strictly to agreed-upon domain terms. The developer confirms that when any attributes on the route specification are changed, they will delete the old itinerary. Finally, they ask the routing service to generate a new itinerary based on that updated route specification. This second conversation is shorter, highly specific, and exactly matches how the operations team handles real cargo. These spoken words map perfectly to the codebase. This explicit language limits system behaviors to what the business requires. To maintain precision, domain experts must reject unfitting terms, and developers must challenge ambiguity. This continuous negotiation is the team's most critical structural work. When developers and experts use the exact same vocabulary, the software architecture inherently mirrors the business model. This practice introduces a real-time testing mechanism known as modeling out loud. Team members describe scenarios verbally, using only the specific nouns, verbs, and relationships allowed by their current domain model. If a sentence sounds awkward or forces a logical contradiction, the team hears it immediately. It acts as a compiler error in everyday speech. This instant linguistic feedback forces the team to iterate on the phrasing, refining the concepts until the domain logic flows smoothly. Speech becomes the ultimate test suite, exposing architectural flaws long before a single line of code is written. A common mistake is assuming that a ubiquitous language is achieved by writing a glossary document. These glossaries fail because they quickly disconnect from the daily conversation of the team. As the team works, they discover new domain insights. The static document is rapidly rendered obsolete by these breakthroughs. The true carriers of the language are the team's ongoing speech and the system's source code. If the terms explained in a design document do not show up in conversations and code, the document is dead. Teams must be ready to abandon documentation that cannot keep pace with the spoken language. A language achieves ubiquity only if it is actively spoken and executed, not safely archived in a folder. A change in the ubiquitous language is a change to the model itself. When the meaning of a term changes in a meeting, the team must immediately refactor the code to reflect it. This means renaming the classes, updating the methods, and rewriting the unit tests so they match the new language perfectly. Ignoring this step reintroduces the translation tax. The definitions drift, and the architecture begins to rot. The objective is zero translations between domain experts, software developers, and the codebase. By aligning the vocabulary of the team with the vocabulary of the code, you ensure the software structure remains a faithful reflection of the business it serves.